Let us start this. Okay, now look over here. So we got to know that what happens during head-on elastic collision. So this is a perfect example of head-on elastic collision with equal mass, isn't it? Actually, this gives us the total. If it has, then velocity gets interchange. If we have head-on elastic collision in such a way they have the equal mass. Are you able to get me or not? Isn't it? So let's suppose I'll take an example. Let's suppose there were two balls, and if they are of equal masses, okay, this is m, this is m. Initially, it was moving with 10 meter per second, and this was at rest. So after collision, what you are going to observe? Yeah. Uh, yeah. So you are going to see that this one, this mass has came to rest now after collision, and this one starts to move with 10 meter per second. Okay, so this actually happens with elastic collision. Now let us talk of another special case. Let's suppose we know that velocity v1 is written as, for head-on elastic collision, it is written as twice of I'll directly tell you how to write, twice of m2 into u2 plus m1 minus m2 into u1 divided by m1 plus m2. Are you able to get me? Shit, what is happening? Yeah, 1 minute. Yeah, by m1 plus m2. This was my relation, isn't it? Similarly, if we like v2 is written as twice of m1 u1 plus m2 minus m1 into u2 divided by m1 plus m2. Got it. Now let us take a special case where one of the masses is bigger. Consider, let's suppose there are two balls. Okay. So let us just take an example. There were two balls. Okay. Both of different size. Okay. And they are moving. They got collided and they are moving. Are you able to get me or not? So this is one. This is another one. They have, after collision they have new velocities. Okay. Try to see. Let's suppose this is m1 with u1. This is m2 with u2. So what is going to happen? Try to understand. Let's suppose if this is m1, which is going to move with v1, and this is m2 going to move with v2 after collision. But one thing is there that I put on this one case. If m1 m2, let's suppose whatever it is, m1 is greater than m2, means m1 is too much heavier than m2. So m2 will be considered as negligible, isn't it? Are you able to get me? So let's suppose if this is v1, in case of v1, if I write v1, so this m2 will be negligible, isn't it? So what I'll be left with? I'll be left with m1 u1 divided by m1. So m1 m1 cancel, which is exactly equal to how much? u1. And but m2, sorry, v2 will be written as what? That is twice of m1 u1 plus m2 is gone, cancelled. So minus of m1 into u2 divided by m1. So what I'm left with, that is twice of u1 minus u2. Are you able to get me or not? Means what actually happens is that this b1 is exactly equal to u1, means m1 is still moving same, but m2 moves with twice of u1 minus u. Are you able to get me or not? Is that clear? Are you able to get me? Okay. So this is what actually happens for the perfectly elastic head-on collisions with one heavier mass and one equal mass, and those are my only exceptions which will provide us the cool, answers of each and every thing. Are you able to get me or not? So let us start solving some problems based upon these. Now, this was not see, this head-on collision of perfectly elastic wave was just a generalized idea. In elastic cases, there is no need of such questions. Are you able to get me or not? Elastic and inelastic and perfectly elastic does not have such generalized idea. So look over here. Let's suppose, let I'm writing one question. Let's suppose there are two masses, one of 10 kg and another one of 5 kg. They collided. Okay. Okay, so the question is very very simple. If this 10 kg was moving initially with some velocity, okay, बोल रहा है कि this 10 kg was moving initially with velocity 10 meter per second, okay, and at that time 5 kg was at rest after collision in such a way that E value was exactly equal to 1 by, sorry, 3 by 4. How much was my E value? 3 by 4. Then find the velocity of 10 kg which is V1 and velocity of 5 kg which is V2. बताओ क्या होगा? You have to find V1 and V2. बताओ क्या होगा? Mm-hmm. Yeah, you tell me the answer. कितना आ रहा? अच्छा पहले तो we know that f external is exactly equal to 0. So whatever happens, initial momentum is equal to final. So that is 10 into 10 plus 5 into 0 is equal to 10 into V1 plus 5 into V2. So I can take 5 common. V2 plus twice V1 is equal to 200 by 5, that is 20. Are you able to get me or not? First equation. Second equation is 3 by 4. E is equal to velocity of separation, that is V2 minus V1 divided by U. Yeah, so that is V2 minus V1 is equal to, how much is that? 10 by 6 by 6 by no, no, 1 minute. That is 3 into 10 by 4. That is 2 5 is 10, 2 2 is 6, 2 2 is 4. 15 by 2. Right on. Okay, so this is equal to twice V2 minus twice V1 is equal to 15, and V2 minus plus twice V1 is equal to 20. So the equation is simple. So this is V2 is equal to 35 by 3. Are you able to get me or not? And similarly, if I put V1, we'll get 25 by 6 meter per second. So when nothing is given, when nothing is mentioned, follow this principle. Okay, always one thing is common in every collision, that law of conservation of momentum is always fulfilled. So always form first equation through law of conservation of momentum, and second equation will be formed through the energy equation or the given condition of coefficient of restitution. Are you able to get me or not? Okay, look over here. Do the next question. Let's suppose I have a ball of twice m kg, initially moving with 4 v naught velocity, and there is another ball of thrice m moving with velocity v naught. They got stick together and they form a ball of 5n. And I do not know with what velocity it is moving. Are you able to get me or not? So question is, if they are moving with velocity v, then the loss in find the loss find the percentage loss निकालो, percentage loss of kinetic energy. बताओ, find the percentage loss of kinetic energy. हेलो, हाँ मैं क्लास ले लूँगा. हाँ हाँ, तो क्या हुआ? अच्छा. हम्म, ठीक है. ठीक है, ठीक है, ठीक है. चलो फिर मैं क्लास के बाद कॉल करता हूँ. क्यों? ठीक है, ठीक है, ठीक है, ठीक है. Okay, so find the percentage loss of kinetic energy. That's what they have told you to find. So tell me, what is the percentage loss? So what is the meaning of percentage loss? That means that there is nothing of loss or gain. If there is percentage written now, just do one thing. Find the final kinetic energy, subtract with initial kinetic energy. Okay. If it is positive, then it is gain. If it is negative, then it is loss into 100%. Are you able to get me or not? Is that clear? So this is just the percentage change. Okay. It can be loss or gain. Are you able to get me? So look over here. If I want to find the first of all, I need to find the final velocity to get the final kinetic energy. So this is if I apply initial momentum. So I'll directly write 4v naught into 2m plus 3m into v naught is equal to 5mv, isn't it? So this implies v is equal to how much? 4 to the 8, 11 v naught by 5. Is that clear or not? So if I look into kinetic energy initial, how much is that? 1 by 2, 2m into 4 v naught square plus 1 by 2 into 3m into v naught square. If you solve this, I think you will get it around 316 to the 32, 35 mv naught square divided by 2. Is that clear or not? Similarly, kinetic energy final will be how much? 1 by 2. Total mass is 5m into 11 v naught square divided by 5 into 5. I'm directly writing so as to cancel this 5. Are you able to get me? So this is 121 mv naught square divided by 5 to the 10. Got it? So just solve this, you'll get some answer out of it. Are you able to get me or not? So this approximately, just put this relation into this. This approximately comes as 31%. Okay? Huh. Got it or not? Okay. Let me give one more question. Okay, this is an interesting question. Try to do it. Let's suppose there are three balls. One is twice in. Yeah. And another ball. ठीक है. काम करते हैं, डायग्राम ले लेते हैं, काम आएगा क्योंकि क्वेश्चन थोड़ा सा रियली अच्छा है. Okay. So there were three balls. Okay. Each were placed on same level ground. Got it? Hmm. So each were perfectly placed on same level ground. Their masses are little bit different. This is twice m, this is m, and this is also m. This is a, this is b, and this is c. This is moving with velocity v naught, and at that time this is at rest, and this one is also at rest. First question: find is speed of each ball after collision. Second question: total number of collisions occurred. If E was exactly equal to 1 for each and every collision. बताओ. Means this is a, sorry. perfectly elastic collision, isn't it? Hmm. So tell me what happens. बताओ क्या होगा? Okay, let us see that. Okay, let us talk about the first collision first. Okay, case one. First collision which happens between 2m moving with v naught and m which is at rest. So after that 2m moves with some velocity v1 and m. How come the velocity will switch? Masses are different. Masses are different. Equal mass and elastic collision gives us the switch of velocities. V2. So first law of conservation of momentum. So twice m naught v naught is equal to twice m v1 plus m v2. So equation becomes v1 twice v1 plus v2 is equal to twice m v naught. Oh sorry, twice v naught. Are able to get me? Next equation of I can put the coefficient of restitution. So E is exactly equal to 1. That means velocity of separation which is v2 minus v1 divided by v naught minus 0. So this implies v2 minus v1 is equal to v naught. So if you just replace this implies, just try to solve these two equations. V naught v naught v2 v2. I can multiply this with 2. So this implies v1 becomes v naught by 2, isn't it? Okay. And v2 is just exactly equal to v naught. So this is my first collision. Are you able to get me or not? This is just your, yeah. So that means during the first collision, the 2m starts to move with velocity v naught by 2. Are you able to get me or not? Half of its original velocity. And m starts to move with velocity v naught. And while cm, this is a, this is b, and this is c, which is still at rest. So this was my first collision. Are you able to get me or not? Due to this has happened. Are you able to get me? So second collision. Now look over here. B is faster than A or not? So B will just collide with C directly, isn't it? So second collision is directly between B and C. First collision was A and B. After that, A slows down. This implies A slows down. Yeah. So here what will happen, as B is of mass m moving with velocity v naught, plus C, which is of mass m, which is at rest right now. After collision, what will happen? Simple. B will come to rest, isn't it? B will come to rest and C will move with velocity v naught. Are you able to get me or not? Is this clear? So this is B, this is C, this is B, and this is C. So this is the consideration of second collision. Is that clear? So B becomes at rest while C starts to move with velocity how much? 1 minute. Did you just solve? Did we got V naught by 2 or something like that? Can you check how much? Really? Just check it once. I think I'm getting some another answer. Let me check it. Twice V1 plus V2 is equal to twice V naught, and V2 minus V1 is equal to V naught. So with 2, so this and this got cancelled. Thrice V2 is equal to 4 V naught. Oh, so V2 is equal to 4 V naught by 3. So V1 is equal to just V naught by 3. Okay, 1 minute. So, but still the answer will remain same because previous one was heavy one. Once the conclusion still remains same. Okay. Okay, 1 minute. So look over here. V1 we got. Let's suppose if I put, so V1 we got to be V naught by 3, while V2 we got 4V naught by 3. So V2 means what? V2 is the velocity of the rest mass initially, isn't it? So whatever happens, twice m is moving with V1, and this one is moving with 4V naught by 3. This one is at rest. So whatever happens, this velocity is more means B's velocity is more, so A will be not be able to catch it. So 4V naught by 3, which is at rest. So M comes at rest and C starts to move with 4V naught by 3. Are you able to get me? This is clear. Now, 1 minute. So after getting 4V naught by 3, that means what happens for the third collision? Because see, try to understand. A is still moving. This A of us is still moving, while B has came to rest after the second collision or not. So there is a chance of third collision. Means there is definitely a third collision which is going to take place, and that is going to be between A and C. Are you really serious? A and B once again. Why? A was moving with V naught by 3, B came to rest and C is moving with 4 V naught by 3. So there is once again the collision between A and B. Okay, and then A and B will have their own different velocities. Okay, so let us see that how they what they attain. So A, which is moving with, not right A, this is 2m. A, which is moving with V naught by 3, collides with B of mass m, which is at rest. So after collision, B means A twice m move with new V dash, V1 dash, and B of mass m moves with new V2 dash. Is that clear? So once again, what is going to be my V1 dash? As you saw that the whole relation, I'll tell you one trick how to do it. Once again, you can write the equations of conservation of linear momentum and coefficient of restitution equation. But there is one trick. See that the velocity is getting reduced by a factor of 1 by 3 or not. So once again, this v1 dash is going to be whatever was the original velocity, it will be a factor of 1 by 3 for that. Yeah, is that clear? So this becomes v naught by 9. v1 dash is v naught by 9, but in forward direction itself. Are you able to get me? And similarly, if you find for b also, you can just put in this equation. I'm utilizing this equation only, this equation which we have created right now, but in a different way. Okay, so v2 dash 4 v naught by 9. Got it. So what you got to know, what you got to see, there are total number of how many collisions? 3 collisions, isn't it? And after the collision, how the bodies are moving? They are moving in such a way that 2m is moving with velocity v naught by 9, m is moving with velocity 4 v naught by 9, and third one m is moving with velocity v naught by 3, 4 v naught by 3. So look over here, this one is more, this one is little bit less, and this one is little bit less. So after 3 collision there is no more collisions. Are you able to get me or not? Got it? Okay, can we move ahead? Let us take one more example. The There is mass 2m which has velocity v naught. Okay, and there was mass m which was at rest at that time. Okay, so the question is simple. First, find the speed of m and 2m after collision. Okay, second, impulse of reformation and deformation. Impulse of deformation and reformation, such that here E between the balls is 1 by 2. Third, max loss of kinetic energy during collision. Now, at least you find the velocity first. Find the v of m and 2. I'm sorry. After collision, impulse of deformation and impulse of deformation, and maximum loss of kinetic energy during collision. V2 is equal to V naught. Are you sure, really? V2 is equal to V naught. Then V1 is V1 is equal to V naught by 2. Let us see that. Correct. It is correct. So let us see. So velocity finding is easy. So 2m moving with velocity V naught. Then I have m which is at rest, isn't it? Now they collide. So if they will collide, they will deform. To find deformation or reformation, you should always consider the deformation case. Okay. M, which is going to move with common velocity, and then after separation, 2m will move with some another velocity v1, and m will move with some another velocity v2. Is that clear? This is u1 and this is u2. Got it? So let's suppose if I apply the energy equations, sorry, linear conservation of momentum equation without thinking about this case. So I'm considering this as initial and this as my final. So if I consider this as initial and final, equation will be twice m into v naught is equal to twice m into v1 plus m into v2, or equation becomes v1 plus v2 twice v1 plus v2 is equal to twice v naught. Second, elastic energy means coefficient of restitution case E is equal to 1 by 2 velocity of separation, which is v2 minus v1 divided by u1 minus u2, which is v naught minus 0. So this implies v2 minus v1 is exactly equal to v naught by 2, which can be also written as twice v2 minus twice v1 is equal to v naught. Are you able to get me or not? So the equation becomes twice v1. So this implies simply v2 is equal to exactly v naught and v1 as exactly v naught by 2. Are you able to get me or not? So this is moving with half of its original velocity, and this is moving with the velocity taken from the particular case of the 2m mass. Are you able to get me? Is this clear? Now the question arises that when they were in this deformation and deformation phase, what was their common velocity? That's a big question or not? So let us just do the calculation about the intermediate phase. Yeah, impact phase. Let us write, we have got to know. So the word impact phase. Look over there, they are moving with common velocity. So I can write the equation directly. Twice mv naught is equal to thrice m into v. Cancel. Or v is equal to twice v naught by how much? 3. Are you able to get me or not? Is that clear? So what is my impulse of second question? Impulse of deformation. First of all, what is ID? Simple. See, from here to here there is a deformation or not? What is present? Deformation, isn't it? And from here to here there is a reformation. Are you able to get? So impulse of deformation is nothing but final change of momentum minus initial change. Initial momentum finally is thrice m into v plus initial minus initial momentum was twice m into v naught. Are you able to get me or not? So thrice m into v means what? Thrice m into twice v naught by 3 minus twice m v naught. Are you able to get me? So what do you observe? That is it going to be zero? It's coming out to be zero. Wow, wow, wow. Acha, 1 minute. Sorry. I just forgot one. Wait, 1 minute. First of all, we should understand to that particular concept of deformation. You look over there when I just taught about impulse of deformation and reformation. We used to always take only one mass, no? We used to write the equation of only one mass, isn't it? So here also, when it is asked, remember that momentum is for the system, but impulse of reformation or deformation is only for one mass. So let's suppose if I define for this is A, B, ha. Yeah, let us see. If I write impulse formula, what is that? Integral f dt. Now, if you apply the force can't be applied on two objects at the same time. No? Force cannot have so that is why it is a unidirectional body. So this is why we write on one body. Are you able to get me or not? Okay, but momentum, we see momentum is also a unidimensional, one-dimensional object, but I am considering the net f external on the whole system to be zero. That's why I'm able to write the initial momentum of the system plus initial momentum of the system is equal to final momentum of the system. Okay, so id of, let's suppose if I take block A, so that is going to be twice m into velocity v minus twice m into v naught. So this is twice m into velocity v, which is twice v naught by 3 minus twice m v naught. How much is this going to be? 4 m v naught. 4 to 8. So minus of 4 minus 4. 4 आ रहा है क्या? 3 to the 6. Twice mv naught by 3. Yeah, is that clear or not? So that is correct. It is feeling that impulse is working for A on which direction? If this is A, so the normal is working in opposite direction, so that is why impulse is working. For mass M, let us check ID of B. So that is M into, final momentum is M into V minus M into 0, isn't it? So the look over there, you are going to get same thing twice mv naught by 3. तो दोनों के अंदर impulse same आ रहा है deformation का, but the directions are different. Yeah. Similarly, impulse of reformation, if we calculate I of r of A, let's suppose if I calculate of A, so what will be that? What will be the equation? It is I am getting twice m of v1 dash, अच्छा v1 आ रहा है ना, ठीक, twice m of v1 minus twice m का v. Are you able to get me or not? So how much is that? Twice m v1 is v naught by 2 minus twice m into twice v naught by 3. So this is going to be appearing as कितना आ रहा है? It will be 2 to the 4, 3 to the 6, 6 minus 6 minus 2 to the 4 to the 8. So ये आएगा IR of A is minus of, चेक करना जरा कितना आ रहा है इसका, 6 minus 8 MV naught. So that is minus of MV naught by 3. हाँ, so for A the reformation is working in which direction? Opposite direction. इसीलिए तो उसकी speed कम हुई. Are you able to get me? Similarly, I can calculate the third one. IR of B. You will get the same answer, but it will be positive MV naught by 3. Are you able to get me or not? The main question still lies: find the maximum loss of kinetic energy during collision. Now, the question arises that where is my maximum loss? First, you need to identify that. See, to find the maximum loss of kinetic energy, whenever this kind of question comes, when there is maximum or minimum in terms of collision, then you have to always think, let's suppose this is block A, this is block B, and they are colliding. There is a deformation. Okay. And then they got separated. So always you have to see over here that here is the only possible case where max compression happens, isn't it? Max, that means max compression only, isn't it? So here is only there is a maximum loss of kinetic energy, because after that once again kinetic energy is recovered. Before that already there was a kinetic energy. So you have to always take this common velocity which is present during the deformation phase as the condition for your maximum loss of kinetic energy. Are you able to get me? Hmm. Is that clear? So you have to, uh, you can even consider, means this is what is actually going to be, but when you will apply the equations, you will find out that when you will apply these equations, you will find out that, let's suppose, if I calculate kinetic energy initial, so this is how much, like twice of, this was A was of twice m, and was moving with velocity how much, v naught. This was at rest. Finally, what is happening? This is moving with velocity how much, v naught by 2, and m was moving with velocity v naught, and common velocity is twice m naught by, sorry, twice v naught by 3, I think so. Twice v naught by 3, isn't it? Is that clear? So you look over there. If I find initial kinetic energy, that is half of twice m into v naught whole square. How much is that? This is mv naught square. Final kinetic energy during the maximum compression is how much? Half of 3m. They are joined together 3m, and v naught is twice v naught by 3 whole square, isn't it? So this is going to appear as twice mv naught square by 3. So therefore, it is my maximum loss, or I'm just finding the loss of kinetic energy. That is mv naught square minus twice mv naught, because final is actually less. So that's, yeah, mv naught square by 3. Are you able to get me or not? So that's my loss in kinetic energy. Is that clear? Even you can see that when you will put this one also, you will see that you are going to have the same answer. Are you able to get me? If you put the final kinetic energy as half of twice m into v naught by 2 whole square plus half of mv naught square, this will appear as, I think, twice mv naught square by 3. Let us check that. Is it appearing? Let me check. 2 cancel. So mv naught square by 4. Uh, no, it will not. It will not come. It will not come. So that is not coming. Okay or not? So maximum loss is only going to happen at the point of deformation. Yeah, that was the correct statement which we had predicted. Are you able to get me or not? Is that clear? So let me stop it over here. Okay, I'm left out with oblique collision. Okay, and some more different kinds of collision I'll be doing. Okay,